Hello students, in this module we are going to learn about chapter number 3, playing with numbers. In this chapter you will be learning about factors and multiples, types of numbers, HCF, LCM and their properties. So let us get started. So why to learn? Why to learn this chapter? Where it is applicable? So let us take an example. Here a shopkeeper has 3 cakes of weight 18 kg, 45 kg and 36 kg. If he wants to make these cakes into pieces of equal weight without any wastage, so what is the maximum possible weight of each piece? Here the concept of HCF is applicable. Here finding the HCF of 18, 48 and 54 by prime factorization method, I got 6 as an answer. So here we can conclude that each piece which will be cut off from the respective cakes should weigh 6 kg. So if I cut 6 kg pieces from the respective cake, so from 18 kg cake I'll get 3 pieces, from 48 kg cake I'll get 8 pieces and from 54 kg cake I'll get 9 pieces. Let us take another example. Mrs. Marshall is making party bags for her 25th birthday party. So balloons comes in packs of 4 and whistles comes in packs of 5. So what is the least amount of packs of whistles and balloons Mrs. Marshall must buy so that there is no items left? So here LCM will be applied. Packs of balloons are in 4 and packs of whistles are in 5. So we find the multiples of 4 and the multiples of 5. You can see that 4 5s are 20 and 5 4s are 20. So equal number of balloons and whistles will be at 20. Yes. So 20 is the least common multiple for 4 and 5. So Mrs. Marshall will be needing 5 packets of balloons and 4 packets of whistles. So where we will apply HCF and LCM. So these are the applications of HCF. We will use HCF whenever we want to split things into smaller sections or equally distribute 2 or more sets of items into largest grouping, large number, and to figure out how many people we can invite to a particular event or to arrange something in rows of groups. And for LCM, these are the applications. To know about an event that is or will be repeating over and over, to purchase or get multiple items in order to have it enough, and to figure out when something will happen again at the same time. Now, Ramesh has 6 marbles with him. He wants to arrange them in rows in such a way that each row has the same number of marbles. He arranges them in the following ways and matches the total number of marbles. So, in first case, you can see that number of rows are 6 and 1 column. So 1 multiplied by 6, number of marbles comes 6. In second arrangement, you can see that 2 marbles in each row. So total 3 rows are there. So 2 3s are again 6 marbles. And in third case, you can see he has arranged 3 marbles in each case and he has got 2 rows. So again 3 multiplied by 2, total 6 marbles. He could not think of any other arrangement in which each row had 4 marbles or 5 marbles. So the only possible arrangement left was with all the 6 marbles in one row. That is number of rows 1 and number of marbles in that row are 6. So 6 multiplied by 1, again 6. Yes. Now from this calculation, Ramesh observes that 6 can be written as product of 2 numbers in different ways, as 6, 1 multiplied by 6, yes, then 2 multiplied by 3 is also 6, 3 multiplied by 2 is 6 and 6 multiplied by 1 is 6. So here we can say that 1, 6, 2, 3 are the factors of 6. Yes. Now from here we can see 6 is equals to 2 multiplied by 3. It can be said that 2 and 3 exactly divide 6 with no remainders left. And from other we can see that product of 6 multiplied by 1, the exact divisors of 6 are found to be 1 and 6. So 1, 2 and 3 and 6 are exact divisors of 6 itself. Actually, they are called the factors of 6. Mary wants to find those numbers which will exactly divide 4. So, she decides to divide 4 by the number less than 4. So, in first and second case, you can see that she has divided 4 by 1 and 2 respectively, getting the quotient 4 and 2, leaving no remainder, that is remainder as 0. In third case, when she divided 4 by 3, she got the remainder 1 as well as quotient 1. So, we can say that 4 is not exactly divisible by 3. And in fourth case, she divides the number by the number itself and gets the quotient as 1 and remainder as 0. So, these numbers 1, 2 and 4 are exact divisors of 4. And exact divisors of 4 means they are the factors of 4. A factor of a number is an exact divisor of that number. And observe, each of the factors of 4 are less than or equal to 4, but not more than 4. What are multiples? Multiple of a number is obtained by multiplying that particular number by natural numbers. For example, here you can see multiples of 4. 4 multiplied by 1 gives 4, then multiply by 2, 8, then multiply by 3, 12 and so on. So, we can conclude that 4, 8, 12, 16, 20, 24 and so on are the multiples of 4. Let us see what we have concluded about factors, what we know about factors. For example, is there any number which occurs as a factor of every number? Yes, it is. That is 1. For example, 6. 1 multiplied by 6 gives us 6. 18. 1 multiplied by 18 gives us 18. And so on. So, we can say that 1 is a factor of every number. Now, second fact. Can 7 be a factor of itself? Yes, you can write 7 as 7 equals to 7 multiplied by 1. You will find that every number can be expressed in that way. So, we can say that every number is a factor of itself also. What are the factors of 16? They are 1, 2, 4, 8, 16. Out of these factors, do you find any factor which does not divide 16? No. So, you will find here that every factor of a number is an exact divisor of that number. That means 1, 2, 4, 8 and 16 are the exact divisor of 16 itself. In fact number 4, what are the factors of 34? They are 1, 2, 17, 34 itself. Out of this, which is the greatest factor? Of course, 34 itself. The other factors 1, 2 and 17 are less than 34. Yes, so we can say that every factor is either less or equal to the given number. Fifth fact. Now, the number 76 has 5 factors. How many factors does 136 or 96 have? You will find that if you are able to count the numbers of each of this, even if the numbers are as large as 10,576 or 25,642 etc. or larger, you can still count the number of factors of such numbers. Though you may find difficult to factorize such numbers, but we can say that number of factors of a given number are limited. That means they are finite. Now, fact number 6. Now, let us see facts about multiples. Yes, what are the multiples of 7? Obviously, 7, 14, 21, 28 and so on. You will find that each of these multiples are greater than or equal to 7. Yes, so we find that every multiple of a number is either greater than the number given or equal to that number, but not less than the number given. Second fact, write the multiples of 5. They are 5, 10, 15, 20, so on. Do you think this list will end anywhere? No, the list is endless. So we can say that the number of multiples of a given numbers are unlimited or infinite. In fact number 3, can 7 be the multiple of itself? Yes, because 7 is equal to 7 multiplied by 1. So we can say that every number is a multiple of itself also. What are perfect numbers? Yes, let us see the factors of 6 here. The factors of 6 are 1, 2, 3 and 6. On adding all the factors, I got the answer 12. That is double of 6. So we find that the sum of the factors is twice the number given. So take another example of 28. So all the factors of 28 are 1, 2, 4, 7, 14 and 28. On adding, I got the answer 56, which is double of 28. So the sum of the factors of 28 is equal to the twice the number of 28. A number for which sum of all its factor is equal to twice the number is called a perfect number. Yes, 6 and 28 are perfect number, as addition of their factors gives us the twice of the number. Now types of number. Here we can see that 1 is neither prime number nor a composite number. The number 1 has only one factor, that is itself. There are numbers having exactly two factors, that the 1 number and the number itself. For example 2 multiplied by 1. So there are two factors, 2 and 1. Then 3 multiplied by 1, 3 and 1, and so on. These numbers are called prime numbers, as they have only two factors, that is number 1 and the number itself. There are numbers rather than these prime numbers are called composite numbers. The numbers which have more than two factors, like 4, 6, 8, 9 and so on. Now here we can find prime numbers and composite numbers without actually checking the factors, how many factors they are having, either 1 or 2. So this was given by Greek mathematician Eratosthenes in the 3rd century BC. So let us list all the numbers from 1 to 100 as shown below. So in step 1, you are supposed to cross out 1, because 1 is not a prime number, neither a composite number. Then in step 2, you are supposed to make a square or encircle 2 and cross out all the multiples of 2 other than 2 itself, that is 4, 6, 8 and so on. Now you will find that the next uncrossed number is 3, as 3 is not the multiple of 2, correct? So now again encircle or put the 3 in a square box and cross out all the multiple of 3 other than 3 itself. Now the next uncrossed number will be 5, as 5 is a prime number and it is not multiple of 2 and 3. So encircle 5 and cross out all the multiples of 5 other than 5 itself. Continue this process till all the numbers in the list are either encircled or cross out. Yes, so all the encircled, all the numbers in the squares are prime numbers and all the cross out numbers other than 1 are composite number. This method is called sieve of Eratosthenes. Do you observe any pattern in the numbers given below? Yes, all the numbers occur in the tables of 2. Yes, and all the numbers are found in pairs, like 2, 1, 1, pair of 1, 1, then 4, 2, 2, 4, then 6, 2, 2, 2, 6. So they are called even numbers, and rest of the numbers are called odd numbers and they don't occur in pair. 1, no pair. 3, only one pair, again 1 remains unpaired, right? So they are called odd numbers. Now let us see some facts about number 2. Which is the smallest even number? Yes, the smallest even number is 2. After 2, 4, then 6. Now which is the smallest prime number? It is again 2. 2 is the smallest prime number which is even. The other prime numbers like 3, 5, 7, 11, 13 are odd. Do you find any even number in this list? Of course not. They all are odd. Thus we can say that every prime number except 2 is odd, or 2 is the even prime number. Thank you.